I will be explaining video 4A. A child is standing on the edge of a 3-meter radius merry-go-round that is spinning at a constant rate of 0.3 revolutions per second. What is the magnitude and direction of the centripetal acceleration of the child? Okay, so we're given that the child is spinning at a rate of 0.3 revolutions per second and that the radius is 3 meters. So the circle is the merry-go-round, and the radius from the center to the child is 3 meters. And the child is spinning, the arrow points at 0.3 revolutions per second. Okay, so we need to find the magnitude of the centripetal acceleration of the child. And the equation for the centripetal acceleration is angular velocity squared times r, or velocity squared over r. They're the same. So we need to find the angular velocity since we're given 0.3 revolutions per second, which is the magnitude of the child spinning. So to convert that, we know that 1 revolution is equivalent to 2 pi radians. So to find the angular velocity, we can do 0.3 revolutions per second multiplied that by 2 pi radians to get 1.88 radians per second, and that is our angular velocity. Now we know our angular velocity, and radius is already given to us, which is 3 meters, and we can just use this formula. We plug in the values. For angular velocity is 1.8 radians per second. We square that, and we times that by 3 meters, which is the formula, to get 10.6 radians per second squared. And that is the magnitude of the centripetal acceleration of the child spinning in the merry-go-round, 10.6 radians per second squared. The question also asks for the direction. The direction is pointed toward the center. Why? Because centripetal acceleration is always perpendicular to the velocity. So if you can see velocity is going straight, and if you look at these are the velocity components, you can see that centripetal acceleration always points to the center, which is perpendicular to velocity. So there's a velocity and centripetal acceleration is pointing toward the center. So if velocity was going straight up here, centripetal acceleration would be pointing perpendicular to velocity. So the centripetal acceleration always points to the center. Therefore, the direction is pointed toward the center of the merry-go-round. And this relates to what we've been learning in class as we started talking about angular velocity and this unit. And we learned that centripetal acceleration is angular velocity squared times radius. And we applied that to this situation by using that equation. And we also learned that 1 revolution is 2 pi radians. So that is how this relates to what we've been learning in class. And yeah, thank you.